I was saying that kinematics has got three main sides. We've got one side dealing with graphs. We've got one side dealing with calculus, and one side dealing with like algebra. Normally, you come across this as SUVAT equations. So
Mm.
SUVAT, and this SUVAT has been divided into two. That's the normal straight line motion. So normal straight line, and we've got vertical motion. So free fall. We've tackled this one. We've tackled this one. Today we're going to talk about this one, the first part of the SUVAT, that is the normal straight line motion.
Okay.
With the understanding of the normal straight line motion, you should be able to solve maybe some questions under the free fall. The only thing under free fall is the we're dealing with only one force under consideration, that is gravity. So with that one, we know the gravitational, that is acceleration due to gravity. That's the only thing that comes into play when you're dealing with the free fall or vertical motion. So if you do really understand this one, then the free fall or the vertical motion should be something that will be very very easy for you. So that with the graph. Do you remember we learned the displacement time graph? We learned the velocity time graph as well. And the
Yeah.
basic things when it comes to displacement time graph, we're saying that a line with positive gradient represents constant velocity, those kind of
Mm.
things you should remember. And
Mm.
when it comes to the velocity time graph, a line with positive gradients represents constant
Constant
acceleration,
acceleration.
and
Mm.
the area under the curve over there represents something else. So
Yeah.
I'm going to start this class with that. I'm going to derive the SUVAT equations using graphs. You should read around deriving the same SUVAT equation using calculus. Okay.
Mm.
So in some books, you see this one as constant acceleration formulas. So constant acceleration formula or SUVAT equations. I normally like to call it SUVAT equations. So um, please stick to that one.
Mm.
So there are two ways to derive them. We've got the first one, the graphical method, which I'm going to do with you today, and we'll learn how to derive this using the calculus approach. Is that okay?
Okay.
So I need you to watch some YouTube videos. Interestingly, this is also going to go on YouTube, and I'm telling you to watch some YouTube videos. Anyway, I'm 5 minutes. So
Mm. Mm.
yes. So that is just the introduction for that one. That is a small intro for that. Let's see. Let's come up with a small, or let me say, a nice looking velocity time graph. Nice looking velocity. So velocity time graph. This time I'm not starting from the origin. So let's see if I get straight. This okay. So I'm coming. Yes, let me get some straight edges. How about here? Okay. So first a velocity time graph. What will the line represent? The blue line. What will it represent?
Um, acceleration.
Okay. Which type of acceleration?
Constant acceleration.
Acceleration. That is very good. Okay, so the blue line will represent constant acceleration. So you should see that I'm not really starting from the origin. Normally, this question is the origin. This means that the displacement of the did I say displacement? Displacement of the function goes in zero. Kind of heard of it. So let's move with this one. Initial velocity, we call the initial velocity u. Do you agree? I
Yes,
think
please.
I told you that we're going to use u for initial velocity. So we call this one u. What is wrong with my right up? Okay. So we call this one u. I call the final velocity v. Now, if the line is represents the constant acceleration. So I can now say that the gradient of the line is actually acceleration.
Yeah.
Okay, so the gradient of the line over there represents constant acceleration. So gradient that is A is equal to V u v minus u over, okay, let's say this is over. If you manipulate this, you have to get v equal to u plus 80. If you manipulate that, you are going to get v equal to u plus 80. Please confirm that for me. Is that okay?
Yes, please.
So let's count our very first SUVAT equation. V equal to u plus 80. Let's try to see if we can get another. Now, what can you tell me about the total distance traveled? Looking at the velocity time graph over there.
Um, the total distance traveled will be the area under the graph.
Okay, so the total distance traveled will be area under the graph. In this
Yeah.
case, I can say that F equals, that is a trapezium. So
Yeah.
the area that can either look at it as sorry, a rectangle, and that is going to be a distance. Trapezium, the area of a trapezium is half u,
Um,
of this. So that is the sum of the power sides. We've got u
yeah.
plus v multiplied by the height of the trapezium. In this case, is t. Do you agree?
Yes, please.
Okay, so let's see if we can do some calculations to this one. Um, first, this can look at s equal to okay, 2s equal to u t as b equal to. Now, at this point, from the first equation, we said v equal to u plus 80. So I can do
Yeah.
the substitution. Wherever I see I can put u plus 80 over there. So I can now write this v as u plus 80. So that should be okay. So u plus 80 plus u again. This should be equal to 2s. Now doing expansions, I can get 2u v plus 80 squared. Do you agree with that?
Is it two U?
2ut.
Ah, okay. Yeah.
Okay, you agree with that one. That is nice.
Yes, please.
Okay, so again, okay, so there is 2s is equal to 2ut plus 80 squared. Now,
Mm.
at this point, I can make x a subject. S is going to be equal to, that is dividing both sides by 2. This is going to u as 1 over 2. Hello.
I couldn't hear you.
I'm saying that dividing both sides by 2.
Mm.
Dividing both sides by 2. Is what it means that s equals to u. Do you agree with that one? Or I should go over again?
So, I understand, but your line keeps breaking, so I can't hear you. I don't know if it's from me.
Hello, can you hear me now?
Yes, I can hear you.
Okay. So
Yes.
okay. So far we've gotten three SUVAT equations. Just wait. Let's see. We've gotten three SUVAT equations. The first one being v equals to u plus 80. The second one being s equal to 1 over 2 u plus v all multiplied by t. Now the third one is equal to s equal to ut plus half 80 squared. Now let's see what we can do again. Now from the first equation, we add v to equal to u plus 80. So this time we're going to make another variable the subject. So which variable? I think let's make u the subject of that equation instead. Okay.
You.
So actually everything is going to be based on two main equations. This equation one and equation two. So to derive those SUVAT equations, all you need to do is make doubles the subject of equation one and put it into equation two. So, so
Okay.
far, that's what we did. We put V into equation two. We got this line equation. So at this point, V equal to U plus 80, I'm going to make U the subject. So from equation one, if I make U the subject, so making U the subject over there, you should get U equal to V minus 80. V minus 80. So we're going to put this one into equation 2. From equation 2, we've got S equals to 1 over 2 multiplied by 2. Now that U is equals to V minus 80, I can write this one as S equals to 1 over 2 V minus 80 plus V all multiplied by 2. Sorry, can you with me?
Yes, please.
Okay, good. So I can now further simplify this one. Take out 1 over 2. There is V, so I can write this one as 2V minus 80. But because of the t outside, let me just multiply through straight away. So this becomes 2vt minus 80 squared. Is that okay with you?
Yes, sir.
So s now becomes multiplying both sides by 1 over 2. Sorry, the bracket so vt minus 1 over 2 80 squared. And that gives us our third SUVAT equation. Sorry, our fourth one, which says that s equals to Vt minus half at squared. So let's see if you can derive another one by yourself. So do the other one. You know the way for it. You know what to do, right? To get
Yeah.
another two equation. So far we've gotten four. So
Mm-hmm.
try to get me another one.
Okay.
Okay, how is that going?
Yeah, I'm trying to make T. I've made T the subject, so now I want to put it inside equation two.
Okay, okay. So if what you are doing is for it, you should get t to be equal to like it's making t the subject v minus u over a.
Yes.
Then you put this into equation one. Sorry, equation two.
But
So
say, how do you know what you're supposed to make the subject?
actually, you're making everything the subject one by one. That
Ah,
is
okay.
going to derive the next one. You see, the first one, v was equal to this. It got as one
Yeah.
equation. V was equal to that. It's getting as one equation. This one,
Okay.
c was equal to that. You can get as another equation. Basically, okay, you just do this as example, and I'll tell you what we are actually doing.
Okay.
So put this into equation two. So this I think your difference of two squares should be very sharp over there. U plus v multiplying v minus u. Do you see any difference of two squares over there?
Yeah.
Okay, so x can be written as 1 over 2a u squared. Is it v squared minus u squared or u squared minus v squared?
It's v squared minus u squared.
V squared minus u squared. V squared minus u squared. Okay, and if you do the manipulation, you have to get 2as is equal to v squared minus v squared.
Plus. Ah, okay.
So v squared is actually equal to um
Two as
yes
plus.
That's
V
2 a.m.
square. A plus. Yeah.
2 a.m. So let me shift this to the side. 2 a.m. So that
Yeah.
is the five SUVAT equations. Do you remember that? I think there was this time I came to your place and you were like, I was like, the SUVAT equations are five. And you were like,
Yeah.
you know only four. They are
Mm.
actually five. So
Okay.
let's write down a summary of everything that we've done over there. Let me just go to the bottom so that we summarize everything. Okay, so the first one I can talk about will be uh, v equal to u plus at. The second one that we've been using to derive this, you remember s equal to 1 over 2 u plus
U.
v multiplied by t.
Yeah.
Third one is equal to, sorry, the third one gives us s equal to ut plus 1 over 2 at squared. The fourth one is equal to, sorry, it gives us s equal to vt
VT
minus 1
minus
over 2 at squared.
square.
And finally, the fifth one should be equal to v squared equal to u squared plus 2as. Now, looking at the first one, at every point in time, you see this equations are called the SUVAT equation because it contains the SUVAT. I mean, the kinematics terms. That is, the displacement is s, the initial velocity is u, the final velocity is v, the a is acceleration, and t is the time. Looking at the first
Mm.
equation, actually not just the first equation. Looking at all the five equations, it contains four variables. Four variables. The first one contains u, v, u, a, and t without s. So it means that the
Yeah.
first one, if you're looking for s, you can't use this one. You can't use this one. The second one contains S, U, V, and T. It means that if you are looking for A, you can't use this one.
Okay.
This one contains S, U, T, and A. If you are looking for V, you can't use this one. This one contains V, S, T, and A. If you are looking for U, you can't use this one. And finally, if you are looking for T, you can't use this one. So if you know all these four, you should be able to find anything at any time because it depends on what you are looking for. If the question gives you three missing terms, it becomes very, very easy. The majority of the cases, you're not going to get the question providing you with three terms. But
Mm.
for building of concept sake, we're going to solve questions providing you with three terms. Now, if your substitution into equations is very bad, then it means that there's going to be a real big problem. But if it's very good, you should be good to go. Now, every equation has got its own downfall. Like I was saying, it doesn't really contain all the variables. Normally, the second one is missing. I think that was what we were missing the other time we were talking about the SUVAT equation, right?
Mm.
That's what we were missing.
Mm.
Yes.
Mm.
So normally the second one is missing. You will see the first, the third, the fourth, and the fifth. So the good thing is that if you know about three of them, you can manipulate the three to find another variable, then find another variable. But it's going to make your work lengthy. If you know the five, it's good. So you can stick to the five. It's not so difficult to memorize this homework. And even if you forget, you should be able to derive them. So I just did the formulas using the velocity time graph, using the two main ideas of the velocity time graph. The first one being the gradient of the line when it comes to velocity time graph, and the second one being the displacement when it comes to velocity time graph. The gradient represents acceleration. With that one, that gave us the first one that is being equal to fluctuation. The second thing about the velocity time graph is the displacement, where we say that the area under the curve becomes the total distance or total displacement traveled. And I think the other time we were talking about when the distance is not the same as displacement in the velocity time graph. Do you remember? I was like, if
Yes.
the distance won't be the same if a portion of the graph under the x-axis or the time
mm,
axis of the
mm.
velocity. So that one, the displacement and the distance will be the same. But with this one, I'm taking everything, the distance and the displacement will be the same in this case. So with this one, that gave us the s equal to 1 over 2 u plus v multiplied by t. Now making each variable the subject v is already the subject over here. Substituting v into equation 2, you get equation 3. Making u the subject, you get equation 4. And finally, making C the subject, you're going to get equation 5. And that is going to give you a 5 SUVAT equations. So it's good to memorize them. And if you think you can't memorize them, just try to know how to derive them. There is an interesting way to derive this using calculator. You can look it up. If you want to use, let me know how. I'll show you that one as well. But
Mm.
I need to give you some of the work to do so that, yeah, you do independent finance. That is going to really pay off. Trust me, doing independent finance. Okay, so that is the 5 main Staff's equations, constant acceleration equation. This is only used in the assumption that the acceleration is constant. It's not every time that the acceleration is constant. The acceleration
Mm.
is not constant, either jet or dot, those kind of things. The assumption over here is the acceleration is constant. So all the questions we're going to solve, we're going to assume that the acceleration is constant. When acceleration is not constant, you can't use any of these five. Um,
Mhm.
with that one, I think it will go to work, energy, and power. Yes, work, energy, and power. That one, if the acceleration is not constant, you can still get our way around it. Uh, if the acceleration is not stated to be constant, for this session, because we are doing kinematics, we're just going to assume that acceleration is constant. But when you continue to move, that is the very moment you do work, energy, and power. If it's not stated that acceleration is not constant and you use SUVAT equation, you're going to do that. So if the total score is about 6, you're going to get 4 out of 6. And I do tell my students that, well, it depends on how well you understand the work, energy, and power. After all, it's 2 marks that you're going to lose. So it's better to risk the 2 marks than to lose everything. But I know you are very good, so you won't have any issues with work, energy, and power for you to risk losing 2 marks. Okay, so there's the 5 things you'll be using. Let's go to the question aspect of today's class. We're going to talk about how many questions? 10 questions. It's about training over here.
Mm.
So don't mind my accent. It's not so nice. A car traveling at 6 meters per second accelerates at 2 meters per second squared. Again, the assumption over here is acceleration is constant. Uh, Calculate the speed 8 seconds later. So with this one, we start with SUVAT. Please, anytime, just state the SUVAT. It's something that is going to guide you. I know you don't really need everything over there, but you need to write this one. It's important. It directs your working. So
Okay.
SUVAT, what is the initial velocity of the particle?
Um, the car travels at 6,
6. Okay. What is the acceleration of the particle?
2 meters per second. So
2 meters per second squared. And finally, the time is
8.
okay. So I need an equation that will use V, U, and A. Sorry, U contains U, V, A, and T. Find V. And also I need an equation to find S. So at this point, I can say that V is equal to U plus AT. Do you agree?
Yes.
Finding the velocity. I'm actually going to find everything over there. Velocity. So V equal to U plus AT. It's part of the SUVAT equations I gave you. In this case, V is equal to U is 6 plus A is 2 times 8. So do the manipulation for me. 16 plus 6. What will you get?
Um, 22.
Okay, so that is 22 meters per second. Okay. Now, which of the equations can I use to find S? Which of the equations can I use to find S?
Um, you can use the second equation.
the second equation. Well, in this
Yes.
case, I think I can use any of the equation that contain s. Any of the equation
Ah,
that contain.
okay.
Do you know why? I think
Because you
V,
have
V.
okay.
But that is another risky thing. So what I normally tell my students is that you don't risk when it comes to examination. You don't risk anything. You only risk when you don't have any other choice. You see,
Okay.
if I use V in my next calculation, just assume that the V is wrong. What is going to happen to my next calculation?
I'll also be wrong.
Right, good. So let's say I did this one correct. Sorry, V equals 6 plus 8, 2 times 8. And instead of writing 22, I wrote 21. If I am to use this value in the next calculation, it's going to be wrong. Even though this one is just, let's say, maybe an oversight. I was going to write 22, but I wrote 21. So you always try not to use values you've calculated for in solving your next question. So that
Okay.
is an advice from me. Always try to use values, try not to use values you've calculated for in your next calculation. You only use them when you've got no other option than to use them. So with this one, you won't see me using it. You won't see me using an equation that contains V. Instead, I'm going to use an equation that doesn't contain V, so that when if it turns out that the V is wrong, it won't affect my other calculation. So with this
Mm.
one, I can say that S is equal to UT plus half AT squared. And doing the necessary substitution, S is equal to U is 6. The time given was 8 plus 1 over 2 or 0.5. The acceleration is 2. And the time given is 3. This is squared. So punch everything on the calculator and give me
112.
okay. So 112 meters. That becomes the answer. But if you trust your answer that you calculated in the previous calculation, you can use it in your next calculation. But I
Mm.
wouldn't do that unless I don't have any other option. But perhaps there is another option to use something that won't involve some a value I calculated for. I always take that part because you don't know what you did. So if it's wrong, then your next calculation is going to be wrong. I won't risk that, especially when it's examination. Maybe if I'm working or I'm practicing, I may use that. Even that one, I don't take risks that way. I take calculated risk. No. Okay, so that is the very first example. I think that wasn't so difficult, and that is good. That wasn't so difficult. Let's see what we can do about this one. Okay. So try your hands on this one first, then I'll come in. A car
Okay.
initially traveling at 8 meters per second accelerates at a constant rate of 3 meters per second squared until it's traveling at 17 meters per second. Find A, the distance traveled while accelerating, and B, the time taken to accelerate. Okay, so let's set up the SUVAT. So setting up the SUVAT, what is was S given? No, I think S wasn't given. What is the U initial velocity? What is the initial velocity?
8.
Okay. What is the acceleration over here?
3.
3. And okay, I think the final velocity was given as 17. So you
Okay.
could use well, did I ever tell you that my favorite is V equals U plus 80?
Mm.
V equals U plus 80. That is so easy. So there is always this is my favorite super equation. V equals U plus 80. So we can do the necessary substitution. 17 is equal to U is 8 plus the acceleration given was 3 multiplied by 2. and do the manipulation and getting the value of t. What is going to be the value of t? I think it to be 3. Oh,
Let me see.
okay. T is going to be 3 seconds. So 17 minus 8 should be 9. And 9 divided by 3 should be 3. Okay. Now we can find another one. Again, I'm
Say
not going to
what? Wait, what did you get?
3. Oh, I'm wrong.
3.
Yes.
Um,
What
because
did you get?
I used a different SUVAT equation.
Okay, which SUVAT equation did you use to find time?
I used
How
the v squared is equal to u squared plus 2as.
v squared equals to u squared. It's raining over here heavily. Plus
Oh,
2 a.m. How can you find time with this one? I was finding time.
you are finding time. I thought they said we should find
Oh yeah, yeah.
distance.
I was breaking rules. I was doing the second one first.
Oh, okay, okay.
Okay, but you were finding s, so
Distance, yeah.
that's cool. So s is equal to as the subject over here. It's complete waste of time.
Mm,
If that is if you don't really like working with variables, I will do the substitution so that I get familiar with the numbers. I familiarize myself with the numbers. So v is 17 squared, u is 3 squared. Yes, no, no, no. I think 8 squared. Sorry, plus t, the acceleration given is 3, and that distance is what we're looking for. So 17 squared minus 8 squared, sorry, over 6. This should give you s. So do the calculation and let's see what we're going to
mm.
get.
37.5.
That's 7.5. So s equals to 37.5 meters. Okay, so that answers that question. How are you going so far?
It's okay.
It's okay, good. Let's see the third question. Okay, a particle moves along a straight line AB with constant acceleration 0.5 meters per second squared. If the distance AB is 15 meters and it takes 3 seconds to travel from A to B, find the velocity of the particle A. The second part of the question says a second particle is projected along a line parallel to AB at the same time with a constant acceleration 1.5 meters per second squared. If the second particle takes 3 seconds to travel the distance of 15 meters, determine the initial velocity of the second particle. Nice question. Okay, so let's do the first one. Again, we're setting up a SUVAT. So the first particle, the SUVAT, I was given acceleration to be 0.5 meters per second squared, or 0.5 meters per second. If the distance is 15, so s is 15, and it takes 3 seconds. So the thing is, if it becomes very easy, then you get 3 values. So the very moment you've got 3 values, you can find everything over there. So in some cases, you get only 2 values. That makes the constant acceleration a little bit complicated. Like I said, we're starting off with these examples to build concepts. Then later we start solving the a little bit difficult questions, and I'll teach you some basic tricks that you need to know if you want to go through this successfully. Okay, by now you should be able to find the velocity. What is the velocity?
Um, S plus 80 squared 50.
So I think you can use v equal to sorry s equal to v squared minus half at squared to find the velocity. Oh, okay. So what are we looking for? The velocity at A. Is it u or v?
Yes, so it's u.
It's u. Oh, okay, okay. So I can say that s equal to ut plus half at squared. So s equal to ut plus half at squared.
Mm.
And in most cases, I don't really like using the v. That is s equal to vt minus half at squared. Naturally, I don't really like working with negatives. I am a positive person, so I don't involve myself with negatives. So I don't really like using the v. I think it's the only one that contains negative. If you check the five, I know you can
Mm.
manipulate the root to get negative, but in the standard form, all of them are positive apart from the s equals to vt minus half at squared. So I don't really like using the v. And also,
Okay.
the fraction is not commutative. So if you change the position, you're going to mess up everything. Okay, so using f equal to ut plus half at squared, doing the necessary substitution is to get 15 is equal to ut, so u times 3 plus 1 over 2. The acceleration given is 1 over 2 again, times the time, which is 3 squared. For doing this, what is going to be the value of u?
4.25.
Please speak louder. It's raining over here, so I'm
I'm
getting
sorry,
the
4.25.
4.25. Okay,
Yes.
4.25 meters per second. So that's 4.25 meters per second. Um, we don't really need to find a v. Let's go to the second question. A second
Okay.
particle is projected along a line parallel to AB in the same at the same time with constant acceleration 1.5 meters per second squared. If the second particle also takes 3 seconds to travel a distance of that, find the initial velocity. So I think it's the same thing over there. So
Mm.
it's the same thing. There is no difference in the first and second question. It's just that you are going to get a different final value, but it's going to be the same thing. With that one, setting up the SUVAT, that time was 3, the acceleration was given as 1.5, and the total distance was given as 50. So, like I was saying, it's the same kind of SUVAT. So, this
Mm.
U and V were missing. So, the same process, you can find the U over there using S equals to U plus RP. So, do that for me and let's see what you're going to get.
Okay.
So, doing the necessary substitutions, um, that is S equals to UT plus half at squared, 15 equals to 3U plus 1 over 2 multiply 1.5, right?
It's two. Okay.
1.5 multiplying 3 squared. Okay. So, what will you be?
U is 2.75 meters per second.
2.75. Okay.
Yes.
Meters per second. So let's look at something. Let's see if you can answer this question. Um, Looking at the particles, assuming that the acceleration of, you see, in this case, the acceleration of B, the second question, is
Yeah.
greater than the acceleration of the first question. Assuming that the acceleration of the first question is uh, lesser, let's say the acceleration is 0.4, what do you think the initial velocity is going to be? Is it going to be lesser, greater, equal, and why? Without calculation, I
Um.
don't do any calculation. Let's try to look at at times you need to do this so that when you're going wrong, you know that you're going wrong. So two
Okay.
particles are on the same distance in the same time, right? The first one is traveling with a velocity of acceleration of 0.5 meters per second squared. Let's say the second one is traveling with a velocity of 0.4 meters per second squared. What do you think the initial velocity of the two particles would they be the same, or if there is a difference, which one is going to be greater and which one is going to be lesser?
Wait. Say, are you saying there will be an increase in the initial velocity? What's the question?
Okay, so with this one, the
Yes.
acceleration was 0.5, right?
Yes.
And
Yes.
this one, the acceleration is 0.4. Obviously, the
Yes.
second one acceleration is lesser than this. The
Yes.
particles, both of them travel the same distance,
Yes.
and they travel the same distance with the same time. What is going to happen with their initial velocity? The initial velocity,
Okay.
is it going to be
Um.
equal, or is there going to be a difference in the initial velocity? If there is going to be difference, um, which one is going to be greater than the other, and why? Without calculation.
Okay. Um. There will be a difference.
Okay.
This is because for the one that has the most acceleration, the initial velocity will be less.
Okay.
Then for the one with 0.4, which is the smaller acceleration, the initial velocity will be more than the first
Okay.
one.
Why so? It's correct actually, but why so?
Um, I just did it like if they are both if they both have, let's say, the same final velocity and the same time. So if I subtract the final by a smaller initial velocity, it will give me a greater value. That's
Well, we
why I
didn't
said that.
talk about the final velocity. We are talking about
You said
distance. What you said is correct, but the reason you are giving me is not so strong. You see, both particles are traveling with they are traveling the same distance. They are covering the same distance, and
yes.
one is moving faster than the other. So if this is moving faster than this one, it's expected that this will cover less time than this one. But it turns out that they both cover the same time. So it means that the initial speed of this one is actually greater than the speed of this one. That is the only way where they're going to cover the same time. If the speed are actually the same, let's say that the initial velocity is the same as the first one. Let's say they are all traveling with, let's say, 2 meters per second. 2 meters per second. At the end of the 15 meters, the the first particle will use less time because it's moving faster than the second particle. Are you getting it? So
Yes.
the other particle, this particle will use less time. That is, since they both start with the same initial velocity. Because this is moving faster, this is going to get to the destination first. So for this one to get to the same destination at the same time, then it means that there was like head start. I don't know if you know anything about head start. It's like you moving faster than the person. It's not really head start. Is like you cover a distance before you start traveling. It's not really that way. But what I'm trying to say over there is the only way they will get to the same destination at the same time, cover the same distance at the same time, is when the speed of the second one is actually greater than the speed of the first one. If the speed of the first one is greater than the second one, already this one is moving faster. So it's going to reach there way, 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 way earlier than the second particle. But if the speed of the initial velocity of the second one is greater than the first one, the second one, because the speed are the same, let's say that at some point it's going to cancel out and they are going to get to the same destination at the same time. So if you're solving the question at times, you just need to think things through. So assuming this was the model of the question and I solved the question and I'm guessing the initial velocity of the first one to be greater than this one, something should tell me that, hey, there's something wrong, because we're using this to model real life situation. We are not solving the math just for the math purposes. Because
Yeah,
if you
but
go, we are not solving the math because of the math purpose. Like, oh, because you are doing mechanics, you have to solve. There is a reason to what you are doing. So if you go to the field of engineering, you always question yourself, okay, why is this so? So that is should be, everything should be guided by something. So if you are getting the speed of the first one greater than the second one, something should tell you that this can't be possible. Already the first particle is moving faster than the second particle. So if it's moving faster than the second particle and it started with a greater speed than the second particle, there is no way that both of them will get to the travel the same distance within the same time. That is not going to be true.
say, but
That is
can't we also modeling take into account of the final velocity?
so we are not really talking about the final velocity, right? The final velocity actually relies on the initial velocity as well. The final velocity is the end velocity. I was actually asking you about the initial velocity. It was just the end velocity. Let's say like two people are racing. Let's say Usain Bolt and Blake, and they're both going to travel the same distance, right?
Yes.
They're both going to travel the same, let's say 100 meters. And this time there was a tie. Let's say they all traveled 10 seconds for 100 meters. Is this? Yes, I think this is possible. He used 9 point something, right? Both used 9 point
Mm.
something.
Mm.
Is it 9?
I think it was E too.
No, I think it should be 9 point something. Okay, so let's assume that they both used 10 seconds. And this time it was a tie. If the acceleration of Bolt is greater than Blake, so let's say Bolt and Blake, if the acceleration of Bolt is greater than Blake, then it means that the initial velocity, the speed at which Blake started with, should be greater than the speed that Bolt started with before both of them can arrive at the same time, like a tie. If the acceleration of this one is greater than this one, if both acceleration is like let's say 3 meters per second squared, and Blake acceleration too is 3 meters per second squared, if they both arrive at the same time, it means that the speed that they started off with are the same.
Yes.
The speed are the same. So that is what I'm trying to say. So if this one, the acceleration over here is 13 meters per second, which is unrealistic, there's just an example. Both acceleration is 30 meters per second squared, and Blake's acceleration is 3 meters per second squared, and they arrive at the same time. It means that this person started off with a greater speed. This person, Blake started with a greater speed. That is the only way they're going to arrive at the same time. If they both start with the same speed and this accelerates faster than this, there is no way they're going to arrive at the same time. There is no way there's going to be a tie. But if this started with a greater speed, because of this having a lesser acceleration, this can both can now tie up with Blake. So that is just a dynamics of what we are doing over here. So this is just um, it's not really part of the question, but I just want you to get what you are doing so that when you get some answers, you always second guess it. You second check it. You check if what you are doing is actually correct. So if you're getting like you're solving for a question and you got the times to be negative, I'm not expecting you to know that what you are doing is wrong. So these are some basic things you need to know when you're solving this kind of questions. Okay. So that's just by the way. Let's move on to the next question. Because the difficulty level, sorry, is increasing. The difficulty level is increasing. So this is actually modeling braking system. According to driving guidelines, the minimum braking distance for a car traveling at 20 meters per second is 30 meters. Find the acceleration of the car and the time it will take for the car to stop. Any idea as to how to do this one? How many SUVAT values are given?
Um, Two. But um, we can get time from it, or
Are you sure? If two is given, you can't get time from it because you need at least three.
do we always have to use just the SUVAT one, or we can use the other ones that we know,
Which one?
like V is equal to D over T, like those things. S is equal to D over T.
S equal to
We
D
can
over.
use those ones. Can
Oh
you
no
use
no
those
no no no.
ones?
Where acceleration? No no.
Uh,
That one is based on constant velocity. That formula is based on constant velocity. S equal
oh,
to V over. That is constant velocity.
mm,
And this time we are doing constant acceleration. Do you get the difference?
wait.
So what is the first SUVAT element you are getting? I think it should be the speed. The speed,
Yes.
which speed does it represent? 20
According to driving a minimum
meters
braking
per
distance for a car is it V?
Is it the 20 over there? Is it representing the final velocity or the initial velocity?
Um, I think final
The final. Why are you saying that?
because they said braking distance for a car traveling at 20. So that means that is like the last velocity you reach before the car um before the brakes will start kicking in.
Okay, but again, the explanation is very good. The explanation is very good. Again, is it going to, based on your explanation, is it going to be the final or the initial? So that was the velocity before the brake is applied.
Yes.
Isn't it the initial? That was the time before the brake was applied. So the initial velocity over there is going to be 20 meters. If the brake is applied successfully, what will happen to the speed of the car?
It will reduce
Yes, the speed will reduce
the final or to zero.
to zero. So actually, this was giving us three values. So the initial velocity before the car is going to stop within 30 meters range, then it means that the initial velocity of the car should be 20 meters when the brakes are being applied. So if this is lesser than 20 meters, then it can't really, if it's greater than 20 meters, it's not going to stop within the 30 meters range. It's like there is this investigation that has been done that, okay, so but for a car to slow down, to come to a complete rest, then if the car is going to rest in about, let's say 30 meters, then the minimum speed, the particle, sorry, yeah, the distance in 30 meters, the speed of the particle should be 20 meters per second. So if the speed is greater than 20 meters per second, it's not going to stop within the 30 meters range. So with this one, the initial velocity is 20, and if the during the 30 meters, the particle is going to rest, come to a stop. So that becomes the final velocity. So with these three values, you can now find A and T. Derek, are you getting me?
Yes.
Okay.
But how are you okay? Yes, okay.
Any question?
Mm.
Okay. So at the end of the 30 meters, the car is going to come to a stop, and the initial speed is 20 meters per second. So with these three values, you should be able to calculate the deceleration. One thing too, because the car, because the question was talking about deceleration, you should know that the initial velocity and the final velocity, the initial velocity should be greater than the final velocity because it's reducing. Acceleration is reduction in speed. Do you remember?
Yes.
Acceleration is reduction in speed. So I can't talk about deceleration when the v is greater than the u. That is, the final velocity is greater than the initial velocity. I can't talk about v over there, but I can talk about with the deceleration. I can talk about the fact that the u, the initial velocity, is going to be greater than the final velocity. That is the change of speed. So if you take note of that one, so with deceleration, the initial velocity is always greater than the final velocity. You don't need to memorize this one. It should come to you naturally because the final and the initial, if the final speed is greater than the initial speed, the particle was accelerating. There was an increase in speed. If the initial speed is greater than the final speed, the particle was reducing speed. There was a change in speed, all right, but the speed was decreasing. So there is deceleration. So this stuff should come to you normally. Okay, so with this one, you should be able to calculate the deceleration of the car. So with this one, the deceleration, I'm very sure I'm going to get negative. And if you know that negative acceleration increases deceleration. So let's solve this one. I can use v squared under favorite in that equation. V squared is equal to u squared plus 2as. Okay, so v squared equal to u squared plus 2as. V was given to me at 0, so 0 squared, the u is 20 squared plus 2, the acceleration is 3, wasn't given, but the S was given as 30. Okay, so with this one, you can okay.
Um, acceleration is
Sorry,
negative.
this should be A instead. So this is negative 400 is equals to 60A, and if you do the manipulation, what will you get for A? What are you getting for A?
Negative. Yeah, A is negative 6.67 meters per second
6.67. So there's the
squared.
acceleration.
Yes.
Yes, this is the acceleration. The acceleration is negative 6.67. What is the deceleration?
Is 6.67 meters per second.
6.67 meters per second squared. It's good to know the difference between them. So this is deceleration and this is acceleration. So the acceleration is negative 6.67 meters per second squared. The deceleration is 6.67. If you make a mistake of writing the deceleration to be equal to negative 6.67, what does it mean? Deceleration is equal to negative 6.67.
That means it's rather acceleration that is
Yeah, that
6.67.
that means the particle is rather accelerating. So that is very good. I think we can solve the second one. We solve this one. And the time, you can find a time and be good to go. So work out the time and let's see what you're going to get. So again, try your best not to use values you calculated for. Okay.
Okay.
Try your possible best not to use values you calculated for. So with this one, I think you can use T. Yes. So this is where the second equation comes in. Do you remember S equal to 1 over 2 U plus B multiplied by T? But please, if you don't
Yes.
remember this one, like I said, you don't really use this one. If you don't remember this one, you can use any of them. So in this case, you don't have any other option than to use the value you calculated for. Are you getting me?
Yes.
Because if you don't know this one, then it means that you need to use something that contains acceleration and the time. But because I know this one, I put in the values and I'm good to go. So x equals to 1 over 2. The u given is 20. The v is 0 times the time. Oh, so the x given was 30. Let me cancel this. So, then we can, the time is equal to 3. Please check for
3.
me.
Yes.
Yeah, 3
Yes.
seconds. The time is 3 seconds. Okay. So that is very good. Eh, that is very good. So I think we are getting what we're doing. The difficulty level will be increasing actually. So let's move on to our fifth question. Okay, a car passes a point O on a straight road with a velocity 4 meters per second. It accelerates at a constant rate of 2.5 meters per second squared to a velocity of 9 meters per second. It then decelerates at a rate of 2 meters per second squared, reducing the speed to 3 meters per second. A. Find the distance the car traveled while accelerating. Hence, find the total distance traveled by the car. B. Find the total time the car takes to travel this distance. So I'll give you about a minute to solve this one. Then we solve it together. Is that okay?
Okay.
Okay. So take your time. The difficulty level has increased actually. So relax. Just apply the basics that you know, and you'll be good to go. So you got a minute to attempt this. Okay. So how are you doing this? Can you give me an idea?
Um, I said my initial velocity is 4,
Mhm.
then my final velocity is 9, and my acceleration is 2.5. So I'm
Okay.
using is equal to u squared plus 2as to find
Okay.
my distance.
Okay. Okay. That is not bad. That is not bad. And have you realized that there are two scenarios over there?
Yes.
Okay. What makes it difficult is how to link the two cases. So how do you think we can link the two cases? Case one to the second case. What is the linking factor over there?
They both have the same initial velocity.
Oh no, no, they
Or
don't have the
wait,
same stability. Okay, don't worry. We'll look at
wait,
this.
I didn't.
Okay. Yes. Anyone, any other one? Okay. Don't worry. Don't worry. It has got something to do with velocity, so you are partly right and partly wrong. Um. Okay. Let's set up the SUVAT over here. So the first case, when it was accelerating. So case one. Case one, when it was accelerating. So let's set up the SUVAT over there. And you should know that to find anything, you need at least three of them. Have you realized it now? Like you need at least three before you can find anything with a constant
Yeah.
acceleration.
Yes.
Okay. So S given no, I think S wasn't given. We were given an initial velocity of 4 and an acceleration of 2.5 and a final velocity of 9. That is case one. So
Mm.
let's solve everything of case one, even though the question never asked. Okay, I think the question is even asking for everything. So for case one, let's fill in the. We can find t. So let's find s. No, let's find t first. V equal to u plus 80. I like this one. U plus 80. So v is 9. U is 4 plus the acceleration is 2.5 t. So get me the value of this one, please. So I think it's going to be 5 divided by 2.5.
2.
2. Okay. So the time over there is 2. Let me put the time over there. 2. Let's find the distance then. The distance. I think I can use, like I said, I don't really like using values I calculated for. So I'll use v squared is equal to u squared plus 2as. So v 9 is equal to u squared as 4 squared plus 2 times the acceleration, which was 2.5 times the displacement. So do the manipulations for me. This should be 9 squared minus 4 squared.
13.
Come again.
13.
13. Equal to 13. Equal to 13. Okay, so that is case one. We're done with case one. We filled the SUVAT over there, so you don't have any problem. Let's go to the case two. The second case was when the car was accelerating. So again, let's set up the SUVAT. So SUVAT, this was when the car was accelerating. And we were given the deceleration at a rate of 2 meters per second squared. Now, SUVAT doesn't really take into consideration deceleration. It takes into consideration acceleration, not deceleration. So, what do you think I can do to the deceleration to get acceleration?
Negative 2.
So, the acceleration over here is going to be negative 2. That is very good. Now, reducing the speed to 3 meters per second. So, this was the final speed. Unfortunately, with this one, I've got only two entries. That's that is where the linking factor of the two scenarios, the two cases will come in. So, like I said, it has got something to do with velocity. Now, remember when we were doing the calculus kinematics,
Mm.
I was like, the final velocity at one stage becomes the initial velocity of the other stage.
Mm.
Okay, so let me see if I can draw my weird car. I don't know why my drawing is that bad, but okay, so case one, the car was accelerating. blah 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 blah. So this I'm coming. Let me try to get a perspective over there. Perspective over there is the car was accelerating and it got to the side, the same car, don't mind me, and it started decelerating. So from this side to the side, this is the SUVAT over there. They traveled 13 meters, 13 meters. The speed at this point, let me use a different ink so that I don't mess it up. The speed at this point, that is the initial speed at this point was 4 meters per second. And the final speed at this point was 9 meters per second. This was the case when it was accelerating, and it did this acceleration and covered a distance of 13 meters in 2 seconds. Now, the next case of this is the part where it started reducing speed. So let's say that the car reduced its speed and got to the side. So at this stage, it was reducing speed, but it's still moving forward, right? It's still moving forward.
Yeah.
Now, if I'm to set up the SUVAT using this side, you can see that my initial velocity now becomes the final velocity of the second stage becomes the initial velocity of the second. Sorry, the final velocity of the first stage becomes the initial velocity of the second stage. Are you getting me?
Yes.
Yes. So that is a linking factor over there. So in most cases, when you've got two cases, one thing that can link them up will be velocities. So the final velocity of first case becomes the initial velocity of the second case. And it's not always velocity. At times, it has got something to do with time. So, but in most cases, you get the linking factor to the velocity. So, looking at this scenario again, if that started with a speed of 10 meters per second, it was accelerating and covered a distance of 30 meters in 2 seconds. And the final velocity at the end of the 30 meters was 9 meters per second. That is the final velocity. So, that was the first case. Now, the second case, it started reducing the speed. Now, modeling this one, you can see that the 9 now becomes my initial velocity at that stage. So my now becomes the initial velocity, and the final velocity that I was giving the question as 3 meters per second. Now that we've linked the two cases, we can find the T and S. So go ahead and find the T and S. So find the T and S for me, please. So again, I think you can use V equals U plus 80. 9, sorry, 3 is equal to 9 plus negative 2t. You should manipulate this. I think 3 seconds or so, but do it. 3 minus 9 should give you a negative 6 divided by negative 2 should give you a positive 3. So please check my workings for me. Are we correct? As a time to please.
Yeah, I'm coming. I solved for the first.
Okay, then let me do the S instead. So again, let me use v squared is equal to
Yeah,
u squared.
time is 3.
Okay, so time is 3, and v squared is 3 squared is equal to 9 squared plus 2 of negative 2 and s. And what is s?
80.
18. So looking at the two cases, let's answer the question now. Let's answer the question. The question was asking for the distance. Okay, find the distance that the car travels while accelerating. Hence, find the total distance traveled by the car. So the distance traveled while accelerating was 13. Total distance traveled by the car is going to be 13 plus 8. So total is going to be case 1. The distance traveled in case 1 plus the distance traveled while accelerating 18. So this becomes
21.
8 meters. And similarly, find the total time it takes the car to travel this distance. The total time is going to take the car to travel this distances. 5 seconds. Wow. How can I use the time? Interesting. So that is 5 seconds. Now I can make things more interesting. Then I'll be like, sketch a velocity time graph. So sketch a velocity time graph for the motion. I'm adding it to the question. Sketch a velocity
Oh,
time. Yeah. Are you done with your velocity time graph?
yeah, I'm almost.
It shouldn't take you much time to do this. Okay, so the first case, the initial velocity is 4, the final velocity is 9. And it took us
Okay,
2
I'm back.
seconds. Okay, so initial velocity is 4. Let me just do this one. Okay, so this should be the first case. The initial velocity is 4. Please, the time taken to travel this distance.
2.
2. Okay. Okay, so 2 seconds for this. Uh, so 2 seconds for this. The initial velocity was,
Was 4.
and the final velocity was 9.
9.
And the second case,
Initial 9, final 3.
okay, initial 9, final 3. Okay, so and you should be careful to. You should use straight edges. Curves and other things mean something else. Especially
Mm.
when you know the displacement time well. Oh, this might very here, but you get what you are doing. So that is the
Yeah.
most important thing. So this is 5. This is 3. I should have noted one down. So this becomes the velocity point for the particle. No, they can just be told to do anything at all. They can just be moving one question that is just SUVAT equation can lead to graph, can lead to kinematics. Hey, I said kinematics, I mean calculus, sorry.
Mm.
Can lead to a lot of things. So that is that for this question. Let's see, we're almost through. But as we go, the questions becomes a little bit difficult. So yeah. Let's try this one. 2 points A and B are 8 meters apart and line the same horizontal plane. The particle passes point A with speed of 2 meters per second. The direction of point B. The particle is accelerating at a constant rate of 4 meters per second in the direction of its motion. At the same time, a second particle is passing point B with a speed of 3 meters per second in the direction of point A. The second particle is accelerating at a constant rate of 2 meters per second in the direction of its motion. Determine the time in seconds that has passed when the particles meet and the position at which this happens. This is very interesting. Okay, so would you like to give it a try, or we should start solving it?
Uh, I can try.
Well, at times, like I said, I always say this one. See, when it comes to mechanics, it's not like that's pure math. Statistics do it more or less like word problems. It's not like pure math at all. So anytime you get a question, try to visualize the question in the real life setting, because we this is what most engineers use. Like when it comes to motion, this is what they use. So you try to visualize this. Okay, so there is this point A and B, and two particles are traveling from opposite directions. So what is going on over there? So you ask yourself some basic questions and use that questions to develop your solving process. So it's not like there is this conk formula, like, oh, you have to use this, you have to use that. At times it comes down to how you see the thing and your understanding. That's one of the reasons why most people will complain about mechanics, because they don't really get what is going on. And also they are more into the pure maths, because it's like, yeah, get me a formula and I'll do it for you. But this one, you have to derive your thing and use the formula. So that is one thing that makes it a little bit difficult. Now, looking at this part, let's say we've got two parts. Let me use circles instead to represent what I mean. So, this circle, a red circle, and here's me visualizing what is going on here. Okay, and the total distance or the length of the path is 8 meters. That's the length of the path. Looking at point A, let's say this is my A and this is my B. Reading the question, me visualizing this. Okay, two points A and B are 8 meters apart. So that is what I've done. And lie in the same horizontal plane. A particle P passes the point A with a velocity of 2 meters per second. So that is my red particle with a velocity of 2 meters per second. And mind you, one-headed arrow represents velocity and two-headed arrow represents acceleration. So something like this represents acceleration. Okay. So 2 meters per second. The direction of B, so the arrow should be pointing at B. The particle is accelerating at a constant rate of 4 meters per second. 4 meters per second. So this is 4 meters per second. Yeah. At the same time, when particle passing through point B with a speed of 3 meters per second. So that is passing through with a speed of 3 meters per second. And it has got an acceleration of 2 meters per second squared. If we are talking about motion, we're talking about direction of motion and other things. So this is what the person has. So there are two different classifiers. Now looking at this, Derek, let's assume that this they are going to meet eventually. So let's assume that they met when A has traveled a distance of 3 meters. So when A has traveled a distance of 3 meters, how many meters would have B traveled?
5.
Five. How do you get a five?
Um, The 3 minus the 8.
I mean 8 minus 3 actually, not 3 minus 3.
Sorry.
Similarly, if A has traveled, if they met at, let's say, in the direction of A, they met at 6 meters. When they met when A traveled at a distance of 6 meters, what would have been the distance covered by B?
2.
Okay, so use that basic idea. Set up the SUVAT. So I'll set up the SUVAT of the red one. So SUVAT of the red one. So this one, given the initial velocity of 2 meters per second and a time acceleration of 4 meters per second squared. We were told that at the same time, so the time is the same. If A travels 5 seconds, B would have also traveled 5 seconds because the time was the same. If you check the question, I think some parts of the
Mm.
question, if you're talking about the time being the same. At the same time, yes, the same time. So it means that if A has traveled 10 seconds, B would also have traveled 10 seconds.
Mm.
I guess.
Yeah.
Okay, good. So the time is the same, so that won't be anything. So since the time is the same, let me represent that as t. I don't know the distance that A is going to travel, so let me name that distance S. So that's setting up the SUVAT
But
score.
didn't they say 8? Oh.
The 8 is the distance between the 2 points.
Oh.
The 8 is the distance between the 2 points. So let's say that because I don't know the distance this A is going to travel, I'm naming that distance to be X. Again, let's try to set up the SUVAT for the B. So SUVAT, so I'm using the orange one. Can you see the orange
Yes.
right? Okay.
Yes.
The SUVAT for B, yeah, the initial velocity was given to us as, hey, I think I'm messing things up. The other one I changed. I think I messed up small over there. The red one, the SUVAT for the red one, the initial velocity was 2 and acceleration was 4. Oh, okay, this one, the initial velocity is 3. Sorry. I was using the same arrow, so
Oh.
it was my mistake. I was using the same arrow. This should have been a double-headed arrow. I was confusing myself about it. Okay. So the initial velocity is 3 meters per second, and the acceleration is 2 meters per second squared, and the time was the same. Now this is where the analysis will come into play. Do you remember? I was like, if they met at 3 meters, if A traveled at 3 meters and they are meeting, it implies that B would have traveled 5 meters, right?
Yes.
So
Yes.
if A has traveled X meters, then it means that B will travel
8
8
minus X.
X. So that is the linking factor of the question. So with this we can now solve the question. So this is what we needed. We've got 4 elements over there, so you can solve the question. Now with this one, I've got S, U, A, and T. Because I've got two variables, I don't need anything to do with the V. This V is going to complicate things for me because already I've got two variables over there. And also this V is going to complicate things for me. So I'm going to write everything in terms of what the question gave me. Or what I've got the four things over here. So which SUVAT equation we connect the four elements S, U, A, and T. I think
The third one.
the UT plus R. So the X in this case, X equal to U was given as 2 and the time was given as T. Like we don't know the time that both particles will travel, so it's T plus 1 over 2. The A is 4 and the time is C squared. So that is the relation for this one, the first one. So again, let me try with the second particle. So again, I need an equation that converts 4. It's the same thing. X equals to T plus half AT squared. And this taking from 8 minus X is equal to um, 3T plus 1 over 2. A is 2 and T is C squared. Is that okay?
Mm.
Okay. Okay, let's try to simplify first. X is equal to 2t over here. This cancels out, and this is 2t squared. And this is 8 minus x is equal to 3t. And I think this cancels out, and this will be t squared. Am I right?
Yes.
Okay, good. So at this point, because x is the subject over here, I can replace x by that, or I can also make x the subject over here. Then I use the law of transitivity. So 8 minus 3t minus t squared is equal to x squared. Okay, sorry, x, sorry, not x squared. I'm just grouping like terms. Is that okay? I moved all the t
Yes.
to the left and moved the x to the right. So law of transitivity, there is x equal to this over here and x equal to this. So this implies that this is equal to this. Or better still, we can see this one as substituting equation one. If I'm to name this one as equation one and name this as equation two, I can see this as putting equation one into equation two. But in mathematics, this is applying something called the law of transitivity. So whichever way you take it, you're going to arrive at the same thing. So you can see that you are putting equation one into equation two or equation two into equation one. So let's say equation one into equation two. So this becomes 8 minus 3t minus t squared is equal to 2t um, plus. Hello,
I can't hear you.
hello, Derek.
Yes, sir. Okay. Now I can hear you.
Hello, Derek.
Yes, sir.
Okay, okay. I thought I lost you.
Mm.
So we can group like let's move all the elements to. I think the left should be okay. So 8t minus t squared minus 2t minus 2t squared is equal to 0. We do manipulation, negative 3t squared. Element. This element and this element should be negative 5t plus 8 is equal to 0. So you can solve the quadratic equation using any method of the choice, but for
Yeah.
time
T. Okay.
t is equal to
1.
one and the other one t is equal
That
to,
one is a negative number, so should it count?
yeah, it won't count. Good. So t is equal to 1 second. Now with this, we've answered one of the question. We've been able to calculate the time. Let's check the question again. We are trying the time in seconds that has passed when the particles meet each other. So we found the time to be 1, and now we are told to find the position at which this happens. So because we've got an equation involving the time, that is the t, I think the easy equation would be using equation 1. I can find x. If you use both equations, you're going to get the same thing. But I think let's go with the easy one. I know the value of t. We are solving simultaneous equations. So once I've got a value, one value, in two variables, once I've got one value, I should be able to find. Okay, so with this, from that equation, we're saying that x is equal to 2t
I think 4.
plus, yes, 2t squared. So doing the substitution, this will be x is equal to 2 more going into 1 plus 2 of 1 squared, and s is equal to 4. So they both meet 1 second after traveling 4 meters. Each traveling 4 meters, yeah.
Mm.
So that answers the question. You see the kind of thinking level that went into this question. So at
Mm.
times, just need to relax. It's not all about, okay, I read a question, I put in the values. It's if you go through your mechanics process that way, you always find it to be very difficult, because what if the thing is not straightforward again? Then you'll not be able to manipulate to get to your values. So you have to look at the question in real life. What is going on? Okay, if you try to make a step and see what is going on between the two particles. So if it's only one particle, it's actually very easy. The previous ones, you're just having one particle. But the moment the particles become more than one, or the cases becomes more than one, the difficulty sets in. And if you don't take care, you're going to mess it up. So you just relax, try to visualize what is going on, and try to bring a valid argument, like what we did. If this particle travels 3 meters and they are meeting, it implies that the other particle travels would have traveled 5 meters. So let's generalize things. If this particle is traveling x meters, then it means that the other particle is going to travel 8 minus x meters. Then you take it up from there. So that is one way to go about that question. That is a very challenging question. That is, if you don't really think things through, it becomes a little bit difficult for you. In the textbook I gave you, there is a different way they solve it. You can check that one out too. But I think
Okay.
this is the best presentation. You can check that one out. If you don't get it, let me know and I'll try to do that explanation too for you. Okay. So that is question number 6. We almost done. Question number 7. A man drives the car with a constant acceleration. After 2 seconds of accelerating, he sees a traffic light and slows down with a deceleration of 5, 1.5 meters per second. Given that the initial velocity of the car is 1 meters and the car stops at the traffic lights, find the distance between the traffic lights and the point where it accelerates. You've got 2 minutes to do this. This is actually easy. It's relatively easy. There are two cases over here, and I think you should, when there are two cases, one thing that I think the two cases would be, how can you link the two cases up?
Velocity.
What way?
You said
What way?
initial for normally initial velocity for case one will be final velocity for case one will be initial velocity for case two.
Okay, that is very good. So try to do this one and let's see what you're going to do. This actually very good. The first part is just things that you can but to be able to find the others, then you link the two scenarios, then you're good to go. So do you watch La Casa?
Yeah.
Uh, it's be coming out soon. I just can't wait. Yes. Today is 29.
Yes.
Uh, we are in August.
Yeah.
This Monday is in August. Oh,
It's
so
31.
5 days.
So yeah.
It's not out there. 5 days. I just can't.
Um.
The professor. You know why I like that those kind of movies, like intelligent movies. At times, it makes you question yourself. You realize that you're
um.
not. If you come to that conclusion, it makes you learn more. It makes you
Hmm.
learn. Recently, I started watching it's an old movie, but it also has got something to do with intelligence. I really like those kind of movies. Like it makes me feel stupid because like it's a motivating factor. So I just can't wait to see the professor in action again. Okay, are you done with the question?
No.
Okay, let's see what we can do about this. A man drives a car with. Let's set up the SUVAT first. Definitely, you're going to set up a SUVAT. The car was accelerating, and the second clue it was the after seeing a traffic light. Actually, that is a real life situation. Actually, when you see a traffic light, you are going to decelerate.
Hmm.
Then, actually, this thing doesn't really model real life activities. The reason is that we're talking about acceleration. in life, instance,
Mm,
it doesn't really tell real life something, but at least with this idea, if you go to the one that is not real life, I said the one great for that. The one you're not dealing with constant acceleration, it will be easy for you because you know how to deal
mm,
with the then you move on to. You can't really start dealing with acceleration that is first move on the easy one, then you move on
mm.
to more advanced. Okay, so let's set up a SUVAT. A man tries to that acceleration. The acceleration is 1 meters per second squared. Sorry. After 2 seconds, acceleration he stays at and slows down. Ooh, so that's the first case. So case one, when you're accelerating. Case one, when you're accelerating. So let's separate that one from the case two. Okay, so if you read on, we're told that the initial velocity of the car is 1. So this is 1 meter per second. We can use these three values to find the, I think, the total distance traveled and the velocity, final velocity of the car. So let's do that. The total distance, let me find the V first using my favorite SUVAT equation. V equals U plus 80. V equals U, that is 1 plus A is 4, and T is 2. V should be equal to 9 meters per second. Is that okay?
Mhm.
Okay, good. Now, again, I can use S equals to U T plus half AT squared, not using the V. But I don't really like values I have calculated for. I don't really do it that way. That's one over two. The A is 4 and the T is 3. So please get me the distance traveled. So there should
The
be 2.
distance will be 10. Oh,
Yeah. So this is actually 8 plus 2, that is 10. So 10 meters. So that's the case one. We've been able to fill in everything of case one. Let's
mm.
move to when the acceleration. So case or scenario two. Anything that you can call it, or the case of acceleration and the case of deceleration. So see that again, do that. So for this one we don't okay, we're given the deceleration. We're given a deceleration of 1.5 meters per second square. So it's going to be negative 1.
0.5. Yeah. Then initial velocity is 0. Hey, final velocity is 0.
The final velocity is 0 because it stops. Yes.
Mm.
And now what is
Then
going to be
it will be 9.
good? The initial velocity is going to be 9. This is where the linking value comes in. So the final velocity becomes the initial velocity. So the final velocity becomes the initial velocity. So with these three values, you should be able to calculate t and s. So let's do that calculation. Okay, so again, v equals u plus 80. V is 0. The u is 9. Acceleration is negative, so negative 1.5 t. And you should be able to find t. So what is t?
T is 6.
6 seconds. Okay, t is
Mm.
6 seconds. And also s equals to v squared is equal to u squared plus 2as. So you see the way I try to solve my things, I always try to avoid values I calculated for. I've not
Mm.
met any scenario where I have to use a value that I've calculated for. So if I meet such scenario, then I don't have any other option than to use that value. That is how I've been working throughout. Like that's how I do my mathematics. I don't risk anything. So if there is a value I calculated for and I can use a value that the question gave me, I won't use the value I calculated for. If it's wrong, it's going to affect my other solution. At least if I make a mistake in question one, that shouldn't lead to my distraction in question two as well. So okay, so this becomes 0 squared. The u was given as 9, so 9 squared minus 2 times 1.5 s over there. You know what? Why I did this? I factored out the negative out.
Mm.
I factored out the negative, so you can do it that way. Find my s from then good to go.
S is 27.
27. Okay, so this is 27 meters. Okay, 27 meters. Now let's answer the question. The question says that find the distance between uh, the distance between the traffic lights and the point where it starts to accelerate. So what's the distance between the traffic lights and the point at which it accelerates?
Um, is it 10? Wait, is it?
Okay, let's I we didn't visualize this when we started. That is what is causing this. So let's visualize this. Okay.
Mm,
Is that okay?
yes, please.
So there is this traffic light. How is this a traffic light? But anyway, you guys what I'm doing.
Mm.
So there's red, there's yellow, and there's green. Okay. So a car was moving, a car was accelerating. But at this point, that was accelerating. Mhm. I don't know if you copy the question. Can you read the question from so that we visualize? We should have done this earlier.
Mm.
Okay, so
I
the car
think.
was at this point, and let's say that this traffic light is very far. It's very far from the car, and this is where the car got to before um, the driver saw the traffic light and it started to accelerate. So at 20D, it started to accelerate
Mm.
before stopping at T. So at that point, the car stopped. So the captain was telling us to find the distance between the point at which it started accelerating. So this one it was accelerating. At this point,
Okay.
accelerating, and this point it was at rest. Are you getting me?
Yeah.
So the total distance traveled is what the person is talking about. Is that okay? Or still, hello there.
Um. So it will be 37.
37 meters.
Mm.
So the distance between the traffic light, and the point at which it's accelerated is 37. Find the distance between the traffic light and the point where it accelerates. Yes. So that is 37 meters. And that answers the question. Okay, so it's always very good to visualize what is going on. Then you use that one to solve the question. If we'll not be able to finish up all the questions, I'll give some to you to try. They're all in the book I gave you actually. So
Mm.
let's see if we can solve our last question. We solved about 8 questions. Okay, so try this one and let's see how it goes. An educator ascends from rest with an acceleration of 0.6 meters per second square before slowing down with an acceleration of 0.8 meters per second square. The total time taken is 10 seconds. Find the distance between the stops. Can you visualize this one? So try to visualize this one and see what is going on between. And it's very good that you claimed that when there are 2 cases, one of the linking factor can be developed where the final test of the same. So it's very good if you do that one. You very good to get it wrong when you get a similar question. ascension, we move from bottom to top.
Mm.
Yeah. So there is this elevator with someone in it. Oh, really? If there is someone in the elevator, and that thing comes into play. Mechanics is interesting, and that thing comes into play. Newton's laws of motion. Um,
Mm.
we're going to talk about force, acceleration, and other things. So let's just forget about it. So let's say an elevator. It don't really matter going out those inside the elevator. It's not necessary because we're not dealing with mass over here. Now this is going up. Let's say it's going up. From this point to this point, it took the object 10 seconds. 10 seconds. At stage one, it was increasing the speed. At stage two, it was reducing the speed. So let's try to set up a SUVAT for it. Okay, let me do my red, blue, white. So this is when it was accelerating. I'll try to get them when it was decelerating. So let me use my blue for the second SUVAT. Okay, so with the first SUVAT, we're talking about acceleration. So the elevator ascends from west. So the initial velocity over there should be zero. And it's attained an acceleration of 0.6. Like I said, this question is not talking about constant acceleration. Because we are doing acceleration, we are assuming that the acceleration is constant. 0.6. Before slowing down with the deceleration of that, before slowing down, so it means that we've gone to the second case, deceleration of um, negative 0. Sorry, acceleration of 0.8
Mm.
before coming to a rest. So the final velocity over there is 0. This is all the information that we've got. We can now put thinking into the question.
Mm.
So
For time.
we're told that the total time it took the particle to get to the final destination is 2 seconds. Right.
Yes. Yes.
So the first case, if the particle has traveled 7 seconds, in how long will the second stage take?
3.
3. If the particle has traveled 2 seconds in the first stage, how long will the second stage take?
8.
So if the particle has traveled t in the first stage, how long is going to be the second stage?
10 minus t.
10 minus. That is very good. That is very, very good. Now, another linking factor. Now, there are two cases. One thing that can link the two cases would be the velocity, right?
Yeah.
And in what way? How the velocity link up the two cases?
Um. The fine. Wait. Okay. In this case, the final for case 1 is supposed to be the initial for case 2.
The final for case one is going to be the initial for case one. So if the final velocity of this is x meters per second, then it means that the initial velocity of this is going to be x meters per second as well. Are you getting me?
Yeah.
So that is a linking factor. So you should be able to solve the question. Solve the question for me now. Now that we've got two variables over there. We've got two variables over there. You should know that we are not going to do the s. It's going to complicate our things for us
Mm.
because we've got two variables to deal with over here. So we're going to express everything. And interestingly, we have to use b equals to u plus 80. You
Mm.
can use b equals to u plus 80 in both cases, and it will be good to go. So let me do the red one. So b equals to u plus 80. Um, the v is x, the u is 0, the acceleration is 0.6, the time is t, so x is equal to 0.6 t. With this one again, v equals to u plus 80, the v is 0, the u is x, the a is negative 0.8, and the t is 10 minus t. Oh, yeah, I think 10 minus t. So with this one, I can calculate x. X is equal to negative 0.8 10 minus t. Hey, no, 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 no. This should be positive. This should be positive. Sorry,
Yes, sir.
that should be positive. I moved I moved this negative 0.8 to the other side of the equation, so that should be positive. Now, by the
Mm,
law of transitivity, whichever way you say it, you can use equations, but I still don't want to do transitivity, law of transitivity. You can read around transitivity. The law says that if A is equal to B and B is equal to C, this implies that A is equal to C. This is the law of transitivity. You can read around that. By
mm,
all that you can see it's as equation one and equation two. It
mm,
depends on where you are. If you want to show off small, you're like, okay, using the law of transitivity. It's the same thing. Taking equation one and equation two, that will get you 0.6 t is equal to 0.8 10 minus t. Yeah, you're good to go. So what is 10? Oh, I should be asking that question. 0.8 times 10.
Eight.
That will be 8. 0.8 c. There is 0.6 t. Doing the necessary substitution, as a substitution, and then grouping
Mm,
this yes, and t will equal to
5.7.
5.7.
Mm,
Okay, so 5.7 seconds. We solve for t, and we can also equally solve for x. From equation 1, we're saying that x is equal to equation 1. We're saying that x is equal to 0.6. So I can solve for x over there. So from x is equal to 0.6t.
3.42
Okay, 0.6,
meters per second.
5.7. So x is equal to 3 point what?
42, sorry.
And that answers the question.
Mm.
So it's a little bit lengthy, but if you know what you are doing, you good to go. So that answers the question. So an elevator ascends from blah blah blah, those kind of things, and yeah, is that okay, Derek?
They say, they say we should find the distance, oh, the distance
Right?
between the.
Ah, awesome. Okay, so you can find the distance, right?
Yes.
Yeah, so with the values you can find the distance. So find the distance.
Mm.
So you can use the values in this side and this side. Then, oh, it means that we need to set up another SUVAT.
Mm.
Question is 20. Ah, okay. We need to set up another SUVAT. Do you remember the values? Okay, you've copied them down. So,
Mm.
the SUVAT is red. One, but okay. The final velocity of this one was 3.30. The initial velocity of this one was 0. The acceleration was 0.6. So you should be able to find S over there. Is that okay, Derek?
Yes.
Okay. And towards the V, uh, this one it was accelerating. If I remember, the rate of deceleration was 0.8.
Yes.
The initial velocity times the final velocity is 0. So 3.4. And it is
You don't go want my friend what to draw. No, no, no. I want my friend what to draw. Mm.
the same pattern is around
Go.
there.
I want my friend what to yes. draw. Okay. Let me color. Take it and go. Okay.
Okay. So you can find S for me. The question is so, In this case, I don't have any other option than to use values I calculated for. So
Yeah.
v squared is equal to u squared plus 2s. V is 3 squared equals 0 squared plus 2. That's a little 0.6. Is that so you should be able to do the division. What's the value of over there?
Um, 9.75.
Okay, 9.75.
Yeah.
Very good. Meters, of course.
Yeah.
Now, the next part, again, the same thing. B squared is equal to B squared plus uh, 0 squared is equal to 3.42 squared plus B of 4.6.
That's 7.3.
7.3.
Yeah.
Uh, so could you read that? The stuff, the two stuff, they've got two different distances.
Yeah.
It doesn't really add up. Because normally the first floor and the second floor, they've got the same distance between them. Anyway, let's see. Find the distance between the stops. Okay, so answer from rest going down for the next. Oh, okay, okay. So the distance between the stop is just the summation of the two distances. Are you getting me?
Find the distance
Yes, yes.
between the two stops. Ah, okay, 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 okay.
It was two stops, just two stops over there. So I was taking the deceleration to be like a step over
Going
the.
backwards. Oh.
You see, it was based on the basic uh, how data and other things work. I was actually doubting the answer.
Mm.
I don't know if you realize I was doubting the answer. I was like,
Mm.
how can the top be two different? Looking at first floor and second floor. But I learned that this one, it was accelerating, then it started decelerating. So the
Mm.
total distance is going to be determination. Where's the people before?
17.5.
17.5 meters. So that's 5. You think you started at 4, right? So
Yeah.
4 take. Yeah. I was not able to finish up all the questions. And let's see if I'm actually left with 2 questions. And you can make questions. That's all the questions. I'm going to start questions on Tuesday. Then do a new topic that will be Newton's laws of motion. So kind of motion. I think we finished that one too in about um 2 weeks. 2 weeks almost. Before you go to school, you would have would have completed almost everything under the mechanics. Yeah, yeah, yeah. Mechanics contains 5 mains of it, 5 main half of it, and we will be able to do at least the work energy and power contains a lot of information about it. Laws of motion. The only thing that will be challenging will be the connected particles. The understanding of SUVAT, you should be able to work around the connected particle. So no, no. Yeah, so, we start a new topic. We start a new topic on Tuesday and Thursday, we're going to the Monday. We're not going to solve the past questions on Monday. Instead, we're going to I told you that this aspect I got to do the straight, the horizontal path. So everything we are doing, you can see that is horizontal. We are dealing with the vertical motion that is free fall. On Thursday, we solve the past question. Then on Saturday, I'll come over and introduce you to the laws of motion. Then in about 2 weeks, we finish the laws of motion. Then we do momentum. I can finish up momentum in about 30 minutes. So momentum is very, very easy. Finish up in 30 minutes. If possible, we start the work, energy, and power. Vacation distance is going to be about 5 weeks. So
Mhm.
okay, so that is you can solve more questions on this. Have you written down the question? As the first sprinter in the 100 meters race to accelerate at first okay. Will accelerate at a rate of 5.5 meters per second squared in the first 2 seconds of the race. How far is it? Blah blah blah. This one is a linear question. What do you think the initial velocity is going to be?
Um,
There's a rate. So how would you?
so that means it will be zero because they are now starting off.
So you see where the reasoning will come in from.
Mm.
Yes. Not every value will be in the question. Some you need to reason and get the value. So with that one, you can get that, and you can link up the two questions. And this time, I think we are going to link up using distance. So are you guys copying this?
I'm coming almost done.
Or you can also take a screenshot of it. So you don't
Okay.
need to. So take a screenshot of the page and let me know if you take the screenshot. So that
Okay.
okay. So
Yes.
just look at this question, and this is the 10th question. A
Okay.
car and a lorry equally initially at rest side by side. The lorry moves off at a uniform acceleration of 0.6 meters per second squared. After 10 seconds, the car moves off at a uniform acceleration of 1.6 meters per second squared. Find how long the lorry moved in motion when it overtakes the car, and find the distance traveled by the lorry in that time. So you can also take a screenshot of this and try it out. This is in the first book I gave you. You
Mm.
can also try questions in the second book I gave you. Those kind of questions are a little bit difficult. Try it out. If you've got any issue, let me know. And I'll check out the last question for you too. Um, I I I believe strongly that there is something over there that is.
Mhm.
I'll check that one out for you and let you know.
Mhm.
Okay, so that is all for today's class. Take good care of yourself for me, and we'll meet later.
Mhm. Bye.